So on our 1.3 notes, the front side, let's do another example. So if we look at this example down in the corner, they say in the diagram, JL equals 120. What are JK and KL? Okay, well, what other information do they actually give us in this problem? They give us 120. They give us for the length of JL. What else? Okay, the expression for JK, yep. And so we know that JK equals 4x plus 6. They tell us that. What else do they tell us? KL equals 7x plus 15. Okay, so we got to look at the diagram to get extra information. So we talked about two ways of setting up equations yesterday. Either we were going to be adding two things together and setting it equal to something else, or we were going to be setting two things equal to each other. That was the two setups we talked about yesterday. Which one is this going to be? What do you think? And if you think you know, how do you know? How'd you come up with that decision? The key information is that we know the length of our entire segment from J to L. Okay, we know that whole length. Or if, like in the homework, if they gave us an expression for that whole length, we know something about that whole length. And so because we know that, we know that something is going to equal to JL. We know something about JL. Okay? Well, now JL is broken into two pieces. So this is where that segment addition postulate comes into play. We now know that those two pieces, if I could draw properly, those two pieces are going to then add together to give us JL. That is what our segment addition postulate says. So I can say that JK plus KL equals JL. Okay? I'm going slow on the setup here because I want you guys to understand, because we really only have two setups in this class right now. We're either going to set stuff equal to each other, or we're going to add stuff together and set it equal to something else. And you got to know which one do you do. Okay? Which one do you do? Well, you're going to add stuff together and set it equal to something else if you know something about that something else. If you know something about that entire line segment, which in this case we do. Everybody cool on the setup?
Yeah, dog.
All right, please don't call me dog. Now we're going to move on to plugging in. So JK is 4x plus 6. What's KL? 7x plus 15. And what is JL? 120. So now we need to go through and solve this equation using our Algebra 1 skills. So going through this step by step, please remember you have that barrier for the equal sign. To cross the barrier, we have to use algebra. But if we have stuff just on the same side, then we just combine like terms, right? So 4x plus 7x gives me 11x. 6x plus 15 is a positive 21. Now we need to do what? Subtract 21, absolutely. We got to get the numbers together on the same side, so I'm going to subtract 21 from both sides. Equals 99. Divide by 11. X equals 9. Very good. Okay, but are we done? Is that what they asked us to do, solve for x? No. They want us to find JK and KL. So we have to go that extra step and plug this back in. So we know that JK is 4 times 9 plus 6. So what's 4 times 9? 36 plus 6? 42. There's JK. And KL is 7 times 9 plus 15. 7 times 9? 63 plus 15? 78. Okay, on the backside is that other situation we were talking about for setting things up. They say to use our midpoint here in this example. Q is the midpoint of line segment PR, where what are PQ, QR, and PR? So the key thing here, how do I know how to set up my equation? How do I know how to solve for X? The idea here is I cannot. Now, this is a true statement, by the way. This is a true statement. If I wrote PQ plus QR equals PR. That is a 100% true statement. But there's a problem with doing that. I can plug in for PQ, I can plug in for QR, but I don't know anything about PR as far as knowing a number or knowing an expression to plug in for it, right? I don't know anything there, so I can't do that because that doesn't help me. I get stuck in my first step. So this is a situation where we have to then use the other setup. And the big point here is that we have a midpoint. Q is a midpoint. So somebody please, what does a midpoint do? Divides them just in some way. I just randomly into two congruent segments. A midpoint cuts a segment into two congruent segments. That means we know that this length is the same as that length. Because Q is a midpoint, it's going to cut it exactly in half. Which now means if PQ, line segment PQ is congruent to line segment QR, that means we know the length of PQ is equal to the length of QR. Right? You guys agree with that? Well, then right there is our equation we can use. We can't use the segment addition postulate, but we can use the equation that PQ equals QR. So 6x minus 7 equals 5x plus 1. Now we need to use our algebra. I'm going to subtract 5x from both sides. X minus 7 equals 1. I'm going to add 7 to both sides. So x equals 8. But that is not what they asked us for. They said, what is the length of PQ, QR, and PR? So PQ equals 6 times 8 minus 7. 6 times 8 is 48 plus, 48 minus 7, 41. So that's PQ. We need QR, 5 times 8 plus 1. 5 times 8 is 40 plus 1, which we probably should have known that already. Do we really have to plug in for that? No, because we know that PQ equals QR. So once we know what PQ is, we know what QR is. Okay? And then lastly, we need to find PR. Well, wait a minute. They don't give me any expressions for that. So how am I going to find PR? Adam. Right. We used our segment addition postulate here. We couldn't use it at the beginning, but we can use it now, right? We know that PR is going to be PQ plus QR, or 41 plus 41, which is 82. All right, so let's see here. I would like you guys to try, you know what? Let's keep it simple here. Why don't you go ahead and try number 1. I would like you to try it on your own, and I would like you to discuss it with your neighbor. Go. In working this problem, first thing you need to do is decipher what information you can work with. Obviously, we can work with the information that AD equals 20. That's given to us. We can work with the information that AC equals 3x plus 4, because it's given to us. But did you take a moment to look at the diagram and see where those two line segments are? Yes. I hope you did. Because AD is this guy, and AC is that whole guy. So I could set up two equations right now I could set up two different equations right now from definitions or postulates that we have in class. I could set up a segment addition postulate saying that AD plus DC equals AC. And I could set up an midpoint definition because look, that AD and DC are both marked congruent, right? So therefore, I know that AD equals DC. Right? Right. Well, let's start plugging stuff in here. I know that AD equals 20 because they gave that to me, right? Yeah. So I could say 20 equals DC. Oh, well, look at there. I already found the length of DC. Great. Now I know the length of DC. I can take DC and plug it into here. I already know the length of AD, and they gave me an expression for AC. So I can now write 20 plus 20 equals, and what was it, 3x plus 4? Is that right? Yes. 3x plus 4 is AC. Now I have an equation that I can solve for x. But again, I never would have gotten there had I not looked at my definition for midpoint, noticing that D is a midpoint, or using my segment addition postulate. Why would I use that? Because they gave me information about the whole line segment, A to C. Okay? With me? All right, let's solve it quick. 20 plus 20 is 40. So I have 3x plus 4. If I subtract 4 from both sides, I get 36 equals 3x. And if I divide by 3, I get 12 equals x. So 12 equals x, but I want to find AC and DC. Well, I found DC already. DC was 20. And AC is going to equal 3 times 12 plus 4. And technically, we already found AC, didn't we? Yeah, we found AC right there. If we know AD and we know DC, AC is just going to equal 40. Okay.